equation of tangent formula is equation of tangent, which is we can write as a formula y minus y1 equals to m into x minus x1. This is the formula for the tangent, equation of tangent. So here we just needed to place three things. One is the y1, another one x1, to y1 and x1 as a coordinate, and m, and y and x actually stands for the equation x and y. We do not need to replace it. So here the first question I plan to discuss with you, 1a, the curve equation has been given here at the particular point 2 and 0 we are going to find out. So in that case we can say the x value and y value is given. So in this particular case, for question number a, we can say x1 is given 2 and y1 is also 0. Just we needed to find out the only thing, which is the value of m from here. M is actually the gradient at that particular point, dy by dx at this point. So let me differentiate. Equation is given here, y equals to x square minus 7x plus 10. Let me differentiate dy by dx. We know from our previous working, differentiation of that gives us 2x minus 7. I'm not going to discuss elaborately how differentiate works. So if you want to see my previous work, then we will get it how to differentiate the normal equation. Now at the point x equals to 2, we needed to find out the value of m. This is called the gradient, so you can write as a m. M actually stands for the gradient of that particular point. So put the value 2 into 2, then minus 7, it gives us 4 minus 7, which is minus 3. So now we can write our equation as a, because we know everything, y minus, put your value y minus y1 is 0, so put the value y minus 0 equals to m. We got the minus 3, m is minus 3, and another one x minus x1 value we wrote here the 2, so x minus 2. Now by writing one more line we can find our answer, y minus 3x plus 3 to the 6. So this is our equation of tangent at that particular point. So let's go for the question number b. It is curve equation is given, and similarly there is a point also given 9, 12. So we can find out the equation. We here is our x1 value is 9, accordingly y1 value equals to 12 given. So just we need to find out the value of m. First differentiate it, the expression dy by dx, which is d by dx of, we can write the expression like this, 4 x to the power half, because it is written root x. So if we differentiate it, then we got from here 4 into half x to the power half minus 1, which finally from here you can write 2x to the power minus half. It gives us 2 by root x. Now at x equals to 9, we needed to find out the value of m, which is gradient. At the point we are putting dy by dx, value of x equals to 9. So right here 2 by root 9. We know root 9 is 3, so 2 by 3 is our gradient. Now let's write our equation, which is equation of the tangent y minus y1. Put your value y minus y1, we got 12, y minus 12 equals to m 2 by 3, gradient of this at this point, x minus 9. So now it's actually needed to simplify. 3 you can multiply, cross multiply 3y, say 3y minus 3 12 the 36 equals to twice x minus 9 to the 18. So by writing one more line we can write our answer, which is 3y equals to 2x, which is 36 minus 18, and finally we can leave our answer 3y equals to 2x And 36 minus 18, what is the value of 36 minus 18? Sometimes you can use the calculator, which is 36 minus 18. Let's see, 36 minus 18, the value we got from here 18. Okay, 18. So let's write plus 18. So is it possible to take anything common? No. So that is our answer of the equation of tangent at that particular point. I prepared another question for you, which is equation of normal at to the curve at that particular point. Two different equation is given here. Let us see how to do that questions. First we need to write the equation of normal. What is the equation of normal? Equation of normal, almost it looks like a tangent, but equation normal equation we can write y minus y1 equals to minus 1 by m x minus x1. Actually this is at the point where the tangent stands. At the same point it is perpendicular to the tangent, that's why we have to write the gradient as a minus 1 by m. But the procedure to finding the m is the same procedure the way we did the equation of tangent. Here is the same thing. We needed to put our value y1 x1 and we need to put our value of m. So in the first question it already given the value of x1, which you can write 6. From here we can get, and another value y1 as well 6 given. Now from the equation we needed to differentiate dy by dx. First differentiate it. We got from here 2x minus 5. Now put the value of x, 1 is 6 here, so you can write it m equals to 2 into 6 minus 5, which is 12 minus 5, which is 7. Now equation of tangent, let me write the equation of tangent. Equation of tangent, so just put your value in the equation. We need to know the equation first, which is y minus 6. y1 is 6, from here we took it, then equals to minus 1 by m. M is here 7, put the value here, then x minus 6. Now make it simple by multiplying cross multiplication, which is 7y. We can write it 7y minus 6 7 the 42, equals to, on the right side you can write say minus x, 1 into minus 1 into x minus x, then minus 1 into plus 6, which gives a plus minus minus plus 6. So by writing one more line you can write your answer 7y plus x, take it on the left side, 42 plus 6, which is 48. So this is our equation of tangent, or the answer of this equation question. So let's go for the another one, part B. Let me write the similar way. In part B also x1 is given 4, y1 is also given 12. So just you need to differentiate the expression y written here, x square minus 8 x to the power minus half. Now we need to differentiate dy by dx, which is twice x minus 8 into minus half, then x to the power minus half minus 1. So finally we got from here to the 4 to the 8, which is 2x minus minus plus 4 x to the power minus 3 by 2. That is our expression for the gradient. Now at this particular point we need to put our value, which is 4. So let me write at x equals to 4 our gradient. So I can write here m equals to, m stands for the gradient, 2 into 4 plus 4 to the power minus 3 by 2. This is our expression. We also can use our calculator to do that. So let's say that use a calculator, we can use it. 2 into 4 is 8, then plus 4 into 4 to the power minus 1.5, or we can write minus 3 by 2 is 1.5. So let's see what is the value coming out from here, which is 17 by 2. So you can use this value here, 17 by 2, 17 by 2. Yeah, so this is our gradient we got from our calculation. Now put it in your main equation. We can write here equation of normal, which you can write equation of normal, sorry, I make a spelling mistake, one L is here. So y minus y1, we need to write the y minus, we have the value y minus 12 equals to, then gradient minus 1 over 17 by 2, which is 17 by 2, and on the right side we need to write x minus 4. Yeah, now simplify it. We can simplify like this way, which is y minus 12 equals to minus, if 17 by 2 is written below, we can write is 2 by 17 minus 2 by 17, and on the right side x minus 4. Now 17y, let me write in the linear form, minus 12 into 17. What is the value 12 into 17? Let me take help from our calculator. 12 into 17, we got the value 204. Let me write 204. Then on the right side multiply with the minus 2, which is minus 2x, minus minus plus 4 to the 8. So finally we can write our equation, say 17y plus 2x equals to 204 plus 8 is 302. 204 plus 8, 300, 212. Yeah, so this is our equation for equation of the normal of this equation. So hope you understood the questions we explained. Actually any equation you can solve by using this formula for equation of normal. This is the equation of normal, and for the equation of tangent you can use this equation, and for even the curve is given exponential or the sine logarithmic function, whatever it is, you need to apply these two equations. Let me discuss another question. I planned another question for you, which is equation of tangent and normal. Find the equation of tangent and normal both at the given point. Only the x is given, or the equation is y equals to fx, you needed to consider. So in a single equation you have to do that. So first, for doing that, let you find out the y value first. So by putting the value of x in the equation of x, we can find out the y value. Let we put the equation minus 1 here in our given equation, which is 12 minus 4 into minus 1 plus 2 into minus 1 whole square. So is it possible to do manually? Yeah, almost. 12 plus 4 was the 4, then plus 2, which is 16, 17, 18. So we got the value of y, which is 18. So we have x and y value. Now we needed to differentiate the function. It is given here fx, f of x equals to 12 minus 4x plus 2x square. Now differentiate, we can write here f prime x, which is the form of the differentiation of that expression. Let me write it. So 12 gives us 0, so minus 4 plus 4x. If we differentiate this one, we got like this. So now we need to find out the value of m from here. M is, we can substitute our value of x inside this function f prime x, which is minus 1. Let me put it here. Then we got from here minus 4 plus 4 into minus 1, which gives us minus 4, which is minus 8. Now very simple to form our equation of tangent, because we needed to write our equation, just equation of tangent. Equation of tangent, the formula for that, y minus y1, let me write the formula first. Y minus y1 equals to m into x minus x1. So y minus y1, we got the value of y1, which is 18. We need to consider that value as a y1. and x value is given in our part which is -1, we needed to consider that value as a x1 -1. So put our value from y1 which is 18, and the gradient we got from here -8 x minus -1, so it makes the positive 1 because x1 is negative given. Just now simplify it, we can write it y equals to 18 minus 8x. Take 18 on the right side, then it gives us like this, -8 as well. So our final equation we can write from here, y equals to 18 minus 8 is 10 minus 8x. So this is our equation of tangent. Now let me write the equation of normal. Same thing, just equation of normal is equation which is perpendicular to the tangent. Equation of normal, write the equation first. Y minus y1 equals to -1 by m x minus x1. Same value you can use, which is y minus 18 equals to -1 by -8 here, because gradient we got the -8 from here. This gradient normally stands for the gradient of tangent, and for the equation of normal we needed to make it the perpendicular form, x plus 1 on the right side because x1 is negative. Now we can cut out this 2 minus sign, so let's write here 8 into 8y minus 18 into 8. Let's see the value. 8 into 18, what is the value? 8 into 18, if you 8 into 18 value we got from here 144. This is the value 144. Right there 144 negative 144 equals to on the right side positive 1 into x is x plus 1. So finally you can write our answer as a 8y equals to x plus 145. It does not matter whether you are keeping your x on the left side or right side, so every way you can write, and this is the linear form of this equation. So that is the total thing we discussed today about the tangent and normal. But another class we'll discuss about how does it look, the equation of tangent and equation of normal, how does it look in a curve situation. But this is the without drawing a curve, without any explanation with the drawing, we can find our answer like this way. Just we needed to keep in our mind two formulas are there. Likewise, I prepared one worksheet for you which is the tangent and normal. So here formulas are given as well, and you can find out some of the equation of tangent and normal. This is our key point, key word is tangent and normal we are studying here, and that is the total thing. If you practice, then you are able to do any type of questions from here. And next tutorial I'm planning to discuss with you, that is approximate change. This is another part of the differentiation, approximate change. The total things are here, we will discuss that one in the next tutorial.